If disaster strikes on Mars, help is over 20 minutes and millions of kilometers away. Would you bet your life on an untested fuel plant? You are not just a phone call or an emergency launch away from rescue. A human mission to Mars means nearly 1,000 days trapped in deep space, far beyond any hope of a quick escape or supply drop. Imagine sending a distress call from the red planet. It takes up to 22 minutes just for your message to reach Earth. Then another 22 minutes before you even hear a reply, if anyone can help at all. This isn't a science fiction plot. Space agencies around the world are already planning to send real people, engineers, doctors, explorers, to Mars within our lifetimes. They are working to solve problems no one has ever faced before, knowing lives are at stake. Let's break down how distance, duration, and logistics turn Mars from a destination into humanity's ultimate trial. But what exactly makes Mars so much more brutal than reaching the moon or building the International Space Station? To understand the danger, we need to look at the cold, unforgiving numbers. Think landing on the moon was hard? Reaching Mars is an entirely different universe of difficulty. The stakes couldn't be higher. Either we rewrite history with a triumphant leap to another world, or we risk everything, facing consequences in the harshest isolation humanity has ever known. If we miscalculate these numbers, the consequences are dire. A single mistake could leave astronauts stranded with no way back, turning a heroic mission into a tragedy. The moon sits under 400,000 kilometers away from Earth. Mars, even at its closest, is at least 55 million kilometers out, a gap so vast that it strains our imagination and technology alike. The logistics are even more staggering. A Mars crew needs supplies, fuel, and equipment totaling more than 1,250 metric tons. That is far beyond anything humanity has ever sent into space. By comparison, the biggest rockets in history delivered only a fraction of that mass to the moon. Distance and weight are only part of the equation. Now, let's look at what it takes just to stay alive once you actually touch down on Mars. But as monumental as the distance and payload are, overcoming them is only the beginning. Surviving the red planet itself is the next, even bigger challenge. The Apollo astronauts covered their journey to the moon in just 3 days, but a crew bound for Mars faces 6 to 9 months of travel each way. And once they arrive, they can't simply turn around. The orbits demand they wait well over 500 days on the Martian surface before launching home. That's nearly 1,000 days away from Earth, with no quick routes back and no rescue just a phone call away. The red planet demands solutions for problems Earth has never faced. Mars is not just far away, it's a world that offers no lifeline. Every base must be fully supplied, built, and functional before the first astronaut arrives. Unlike the International Space Station, there will be no friendly supply ships when a filter fails or food runs low. If it's not there when you land, it may never arrive. But the real battle may be in the mind. Imagine years of deep space isolation, cut off from real-time conversation with home by 20-minute communication delays. Conflicts linger unresolved, monotony drains motivation, and every small annoyance can grow into a threat to the mission. The psychological strain is as relentless as the physical dangers. Survival depends on turning Martian air and ice into fuel for the journey home. The plan? Use the Sabatier process to synthesize return propellant from carbon dioxide and hydrogen. But here's the gamble. This technology has never been tested off Earth, let alone under Mars's brutal cold, dust storms, and radiation. A single malfunction could strand the crew forever. And then there's the toll on the human body. A year spent floating in microgravity will erode muscle, sap bone strength, and weaken the immune system, problems that only begin to show up on the 6-month trips to the International Space Station. Mars offers only partial gravity, about 38% that of Earth. That means daily life becomes a test of endurance, with every step, tool, or suit becoming harder to manage and accidents more likely. But let's imagine we overcome all of these barriers and finally land on Mars. What exactly awaits us as we set foot on alien ground? Every unsolved challenge is a potential mission-ending threat, possibly fatal. Mars is a test that will push every system, every person, every plan to their limit. Radiation is an invisible enemy, and it never sleeps. On the journey out and under the thin Martian sky, explorers will face doses that surpass what NASA considers a career-long limit. Shielding can help, but every kilogram of protection adds to the mass, and every extra kilogram means more fuel, more complexity, and more risk to the mission. Colonizing Mars is not building a city. It's managing a life-or-death outpost. Every day is a calculated risk, with no safety net waiting just a call away. Survival hinges on the ability to anticipate every failure and fix it with only what you've brought, or can make yourself. Even the smallest malfunction is a potential catastrophe. Imagine a single valve seizing in the air supply, or a water filtration membrane tearing. Within hours, the situation shifts from inconvenience to life-threatening emergency. There is no margin for error when the nearest help is millions of kilometers away. On Mars, redundancy isn't a luxury, it's the baseline. Every critical system, air, water, power, heat, must be duplicated, triplicated, and able to be repaired without waiting for spare parts from Earth. If something breaks, there are no next-day deliveries. The crew must rely on 3D printing, advanced diagnostics, and autonomous maintenance robots just to keep the habitat running. The Martian environment is not simply cold and distant, it's actively hostile. The atmosphere is suffused with toxic carbon dioxide. Temperatures can plunge to minus 120 degrees Celsius. Vast dust storms can engulf the entire planet for weeks, choking solar panels and fouling machinery. Sunlight itself is a scarce, unreliable resource. So with all these risks and razor-thin margins, why are we still pushing for Mars? What could possibly make it worth the danger, the cost, and the relentless struggle to survive? Nothing outside the base is routine. Every trip beyond the airlock, whether to inspect solar panels or retrieve supplies, is a hazardous operation, planned in minute detail. Spacesuits must shield against radiation, pressure loss, and razor-fine dust. There is no such thing as just stepping outside. Every task is a mission in itself, with real survival on the line. To understand the true draw of Mars, we have to look beyond the hardships and ask, what are the real rewards awaiting those first explorers? And what could humanity gain in return? Up here, the price of a mistake is not just a failed experiment or broken tool. It's the end of the mission. It's life and death, hour by hour, with no room for complacency. The first Martian settlers will be less like pioneers building a new world, and more like the crew of a submarine, living moment to moment in an alien abyss. Mars may be hostile, but it's the ultimate laboratory for the future of humanity. The real mission isn't just to plant a flag, it's to push survival technology to its limits and bring those lessons home to Earth. NASA's Artemis program is already using the moon as a proving ground. Here, technology for Mars, like advanced life support, surface habitats, and resource extraction, is built and stress-tested in lunar conditions, one careful step before committing to the dangers of the red planet. The European Space Agency is leading critical advances in automation and robotics. Their work focuses on smart rovers, autonomous systems, and closed-loop life support, technology that minimizes risk and maximizes survival when human help is months away. Meanwhile, SpaceX is betting everything on the Starship system. Their goal? To transform Mars launches from one-off stunts into a sustainable multi-launch operation. Instead of a single massive rocket, think fleets of reusable vehicles, ferrying people and cargo on demand. The next decade is all about robots paving the way, mapping hazards, and testing hardware. Only in the 2040s will we likely see cautious, stepwise human landings, each one a high-wire act in engineering, medicine, and psychology. The risks are huge, but the rewards could redefine what it means to endure, not just in space, but on our own changing planet. This is not an escape plan. It's an extension of life's playbook, a path to resilience that could rewrite how we adapt, survive, and prosper in extreme environments everywhere. So, as these plans move from blueprint to countdown, the real question becomes personal. If the launch window opened, would you sign up for that journey? But why risk so much? Because Mars is a vast, open-air laboratory where every challenge forces us to invent new ways to find water, generate energy, grow food, and recycle air. These breakthroughs will not only keep future Martians alive, they will feed back to benefit Earth, helping us thrive amid climate crises and resource scarcity. If you knew the odds, would you still volunteer for a 1,000-day journey across the stars? The path to Mars is not a cinematic adventure, but one of real peril, risk, and sacrifice. Every potential volunteer faces the unknown, years isolated from Earth, exposed to radiation, with no guaranteed return, and only the promise of pushing humanity's limits a little further. Ask yourself, would you volunteer? Or would you wait until we are truly ready? There is no right answer, only the courage to face the question. The decision to explore Mars is not just for scientists and engineers, but for every one of us who dares to imagine what comes next. Weigh the risks. A single failure in life support, propulsion, or the untested fuel factories could make the difference between triumphant return and tragedy. Yet the rewards are profound, redefining what is possible and inspiring generations to come. It is humanity's most ambitious experiment in living beyond our home planet. Your voice shapes the future of exploration. Will we choose to leap or stand back until the unknown feels safer? History is made by those willing to risk everything for what could be a new chapter for all mankind. The debate starts now, and your opinion matters. In the end, the journey to Mars is about more than distance. It is a test of our collective will, our ingenuity, and our determination to solve the hardest problems. Will you be part of that conversation, or let the future be written without your say?